During this video, we are going to review the concepts of atomic mass, atomic number, electrons, protons, neutrons, and charge. Okay, first we have to review some basic concepts. Protons, the symbol that we use in order to determine that we are talking about protons is P+, okay? They have a positive charge. Neutrons are the ones that they do not have a charge, okay? So they are neutral, so we're going to use the symbol of N0. Electrons are going to be notated with the symbol E negative, and they have a negative charge. These are the three subatomic particles that we have in the atom: protons, neutrons, and electrons, okay? The mass of an atom, or the atomic mass, okay, uses A, capital A, as its symbol. The charge of an atom uses Z as its symbol, okay? The atomic number is the number of protons that we have in an atom and has a Z as its symbol, okay? And this specific concept, okay, it's important that we consider that the number of protons is going to be equal to the atomic number. And when we have a neutral atom, the number of protons is going to be equal to the number of electrons. Only when we have a neutral atom. If the atom has a charge, or if the atom is an ion with a positive or a negative charge, okay, the number of protons will not be the same as the number of electrons, okay? So once that we have reviewed these concepts, okay, we are going to review some formulas that will help us to determine when we have an atom, which are the subatomic particles that we have, okay? The first formula is that, well, it's a statement in which we said that the Z is the atomic number, and it's going to be equal to the number of protons, which are notated with the letter P+. Okay, A, capital A, is the atomic mass, and it's going to be equal to the number of particles that we have in the nucleus, okay? Remember that in the nucleus we have protons plus neutrons, okay? So P positive plus N0. And finally, the charge is going to be equal to the protons minus the electrons, okay? Remember that in an atom, okay, we have in the nucleus, we have protons plus neutrons, and in the cloud, we have the electrons, okay? So these three formulas will help us to find out, once that we have an element or an atom, to find out how many protons, neutrons, and electrons it has, okay? Muy bien. So we have here the following chart, okay? And they are telling us that we have to determine the missing values. We have the name of the element: potassium, arsenic, manganese, antimony, and oxygen. We have their symbols, and then we have one column that says number of protons, number of neutrons, number of electrons, atomic number, atomic mass, charge, and we have to define if it is an ion or a cation, or if it is a neutral atom, okay? So the first thing that we have to look is we have to look to the information that we have in each one of the rows in order to determine the missing information. So let's look to the first one. We have potassium, okay? We have that potassium has a symbol K, okay? In this case, we are having here a charge of 1. So we have the number of electrons. If instead of having this number 1 in charge, we had a 0, we could write that the number of electrons was the same as the number of protons. But since we have a number of 1 in charge, we have an atom that is not neutral. So in order to determine the protons, we have to either add or subtract the charge, okay? So we have from the previous formulas that we have in the previous slide, okay, we have that charge, it's equal to protons minus electrons, okay? We get it from the previous one, from this equation, okay? So since here in this example of potassium, we have a charge 1, of 1, let me just write it, we have 1, it's equal to the number of protons minus the number of electrons that we have here, which is 18. If we isolate the P, it's going to be 1 plus 18 because we are going to pass this 18 to the left side equals P. So here we are getting that the number of protons that this atom of potassium has will be 19, okay? Because 18 plus 1 is 19. The number of neutrons, okay, is going to be equal to what? Okay, we said that in the previous formula, well, in the formula that we have here, atomic mass, it's equal to the number of particles that we have in the nucleus, which is the same as protons plus neutrons, okay? Since in this example, they are giving me the atomic mass, which is 39, is going to be equal to the number of protons, which is the one that we just got, 19, plus neutrons. If we isolate the neutrons, it's going to be 39 minus 19 because we are going to pass it to the left side, and we get the neutrons, which in this case is going to be 20, okay? The atomic number, we said that it's equal to the number of protons. So this is going to be 19, okay? And the only information that we have missing is if it is an ion, a cation, or as a neutral atom, okay? Since we have a charge of 1, okay, positive 1, we do not have a sign here. We are going to say that this is a cation. Remember that if it is positive, it's cation. If it is negative, it's an anion, okay? If it is 0, it's going to be a neutral atom, okay? Let's make the next one. Let me just erase this. Oops. Okay. Okay. In our second row, we have arsenic, okay? The information that we have is the number of neutrons, the number of electrons, and we have the atomic number. So we can start with the atomic number. Atomic number is going to be equal to the number of protons. So I know that here I will have a 33, okay? Atomic mass, which is the A, it's equal to the number of particles that we have in the nucleus, which is protons plus neutrons. Okay, so in this case, protons is 33 plus neutrons, which is 42. This gives me a 75. Okay, so in here, we are going to be writing 75. Okay, the charge, okay, we know that it's equal to protons minus electrons, okay? So in this case, protons is 33, electrons is 36, so this gives me a charge of -3. And here I'm gonna be writing -3. Since we have a negative charge, this is going to be an anion, okay? Let's make the next one. Let me just erase this. Okay, the element that we have is manganese. The information that we have is the symbol, we have the atomic number, we have the atomic mass, and we have the charge, okay? So let's start with the information that we already have. Since we already have the atomic number tells me the number of protons. So I will have here at 25, okay? Number of neutrons is going to be equal to the number of particles that, the atomic mass is equal to the number of particles that we have in the nucleus, okay? So we have atomic mass is equal to protons plus neutrons. Sorry, this proton should be with the positive sign here, okay? So now what I will be doing is I will be isolating from this equation the number of neutrons, okay? Since for manganese, I have the atomic mass of 55, it's equal to the number of protons, which I have here, which is 25, plus the number of neutrons. If I isolate neutrons, the 25 pass subtracting, and I will have here a 30. So I will be having here a number of neutrons, 30. Okay? The number of electrons, we will be getting it with the charge. Okay, we have the charge, it's equal to protons minus electrons. Okay, so if I have a charge of 1, it's equal to the protons, which are 25, minus electrons, okay? If I reorder this equation, okay, I will have, 1 minus 25, it's equal to minus electrons, minus 24, it's equal to minus electrons. Just let me move it a little bit so we can have it. Minus electrons. If we multiply both sides times minus 1, we will have that electrons is 24. So I will have here a 24. And the final thing that we have to complete is if it is a neutral atom, if it is an anion or a cation. So in this case, since we have a positive charge, this is going to be a cation. Okay, let's make the next one. Just let me. The next element that we have is antimony, okay, which has a symbol Sb, and the information that we have is a number of protons, a number of neutrons, and the number of electrons. And what we have to find out is the atomic number, atomic mass, and the charge, okay? So just by looking to this, we can say that the atomic number, it's equal to the number of protons. So in this case, the number of protons will be 51. So the atomic number is 51. The atomic mass is going to be equal to the number of particles that we have in the nucleus, which is protons plus neutrons. Okay, so in this case will be protons 51 plus neutrons, which is 71, and this gives me 122. Okay, so I'm gonna be writing here 122. Okay, and the charge is equal to protons minus electrons. So charge will be the protons that we have, 51, minus the electrons, which is 54. So charge will be -3. Okay, so I'm going to write here -3. And since this is a negative charge, this is going to be an anion. Okay? And finally, oxygen. Okay, this is an easy one. We have the number of neutrons. We have the number of electrons, and we have the atomic number. Okay? So the number of protons, we say that is going to be equal to the atomic number. So here we will have an 8. Okay? The atomic mass is going to be equal to the number of particles that we have in the nucleus. Okay? So A is going to be equal to protons plus neutrons. So this will be 8 plus 8, which is 16. So I will have here 16. The charge is equal to protons minus electrons. So this will be 8 minus 8, 0, okay? And since we have here a 0, we can say that this is a neutral atom, okay? Doesn't have a charge.